welcome back to our Absolute Beginner series. That's the 8 Caillou ranking. This one's called Function 3, multiplying two numbers. Very straightforward here. Implement a function which multiplies two numbers. So hopefully you know about mathematical operators. If you have some experience, go ahead and try this one, but I don't expect you to necessarily try the challenges if you're absolutely new and don't know how to write any code. So pause if you need to, otherwise we'll get right into it. So the quick solution would be to return a times b. You only had to know that asterisk is the character that denotes multiplication. Yeah, plus, minus, multiply, divide. You can go ahead and test that and submit it if you like. I'm just going to talk a little bit more about classes and whatnot, methods for the people who are absolutely new. So the first thing to note is that you had a class defined here, right? Public class kata. And so a class is just a blueprint. It's how to make objects of certain types. Now remember, we have all the built-in ones. We have int, right? Int, float, string, you know, all sorts of basic building blocks like that. And you could use all that stuff, but it would be pretty cumbersome to work with only those built-in provided types. So the idea of the class then is that you can sort of compose more sophisticated software objects out of these basic built-in types. And so it's a little more human-friendly to think about. You could have public class bear, you know, and then you design it to have the properties of whatever your class is named. So we think about software then in terms of real-life objects that we already know very well. It's sort of making the software world conducive to the way we think about objects in real life. That's sort of what we do with object-oriented programming. And there's two main things with classes. They either have data or they have behaviors. The data, you could also call them attributes, properties. They're just characteristics. So let's use some real examples. In the case of a bear, right, it might have a weight, right? How would you describe a bear? String type, you know, is it a grizzly? Is it a brown bear? Is it a black bear? You could give it an age, and then anything else. However, whatever characteristics of a bear are relevant for your software program. You're not writing everything out. It's just the information that you need to work with your program. And so that's an example of the data. The other part of classes are behaviors. You might call them methods, data, attributes. I'm just giving multiple names. Whatever rings with you, feel free to use functions, right? And so for a bear, right, you might have it, bears can swim, right? And you'd actually have to implement the method, but I'll just avoid that now. It might say climb, and it might say eat, right? Something like that. But the basic takeaway is that there's these characteristics of bears, and then they have these behaviors that they can perform, right? So the class is your blueprint for creating objects. With that then, I'll put our, I lost our, I'll just reset it. So in this case, right, this is clearly a method, and we know methods because they have a certain signature, which tells the compiler that it's a method. They have this access modifier, public or private, that denotes whether the method is accessible outside of the class. Remember, your class is defined by these two curly braces. Everything within those two curly braces is the scope of the class. If I start coding down here, that's not part of the class. So this is a method. It is publicly accessible, which means I can access it outside the class. Private methods you cannot, and just think of it more as sort of the internal workings of your class that you don't need to bother people with. You just want to keep your classes simple to use. You keep a nice small public interface, just a few methods public, ideally. And then you have this optional static modifier here. And the way I like to describe static to beginners is just imagine that it's turning off object-oriented programming. And by that I mean that this method doesn't pertain to specific instances of kata. So imagine you're making a bunch of kata objects or a bunch of bear objects. And with that static keyword that I have here for multiply, it's saying this doesn't really have anything to do with objects. I don't need to create a kata to access this multiply. If I'm coding outside the class in my program, I can invoke it simply by saying kata multiply 2 and 5, right? You can do something like this with a static method. If that method were not static, this would be an error down here. And it would mean that you actually have to create a kata first. You know, kata equals new kata. You have to instantiate it first, and then on your variable, your instance, you can call multiply, and that would be allowed. So this would be, if there's no static keyword, this is what you can do if there is a static keyword, right? And it makes sense for multiply because we're just multiplying two numbers. It doesn't have anything to do, it's not using any of the data of the kata object or the bear object. It's just multiplying the two numbers you give it. So static is a good choice here. Then you come to the return type. It tells you what the function returns. In this case, it's an integer. And then you have your opening and closing parentheses, which take your arguments. In this case, the two numbers to multiply, which are both integers. And we always return, right? To give it, and we have to provide it an integer at the end, and we already said it was a times b. So yeah, a little more insight if you're brand new. Hopefully that helps. Kata's classes rather are your blueprints. They're how you make objects. Why do we make objects? Because we don't want to work with all the built-in types. You know, we don't want to write 100 strings and have them scattered all over the place. Think of it as like an organizational unit where you can organize the data and methods of your software objects. So that should do it for this one. Make sure you test, and then you can submit whenever you're ready. I always encourage to look over the solutions. It's not relevant in this case because everybody probably did the same thing, but in general, they'll show you other people's solutions, and as we get into harder problems, it'll give you new ideas if you scroll through them and look at what other people did to solve the problem. Other than that, thanks for watching. We'll move on to another problem.